Good afternoon all.
Good afternoon, sir.
Now let us discuss about the case study on blood pressure and pulse rate signal monitoring using signals and systems. See, signals and systems plays a vital role in monitoring psychological parameters such as blood pressure and pulse rate monitoring system. See, these parameters provide the crucial information about the cardiovascular systems and identifying the life-threatening conditions such as hypertension, hypotension and heart diseases. See, in this case study, we are going to analyze about the analysis, transformation, filtering, and then processing the signals from stability analysis through how to extract the information, useful information from the noisy psychological signals. In this case study, we are going to discuss about how signals and systems can be applied to biomedical signal processing for real-time health monitoring system.
Objective. The main objective of this case study is to analyze the role of signal processing and system modeling in the development of blood pressure and pulse monitoring system. The main focus is to explain how the signals are captured from the human body and passes through the different system stages, and also interpreted to provide the valuable health information. The focus is on how the concept of signals and systems is involving in improving the measurement efficiency and reducing noise, and also enhancing the system efficiency.
Sir, next I will discuss about the topic of the system overview. In a system overview, we have a lot of subdivisions, sir. Like that, we have a sensing unit and analog to digital converter, and finally to display the output. From this, first of all, we can talk about the sensing unit. In that, we are mainly using two types of sensors, like photo sensor and blood pressure sensor. Like when we can actually see the workflow of the sensor, sir. First, when a sensor is placed in our index finger, it can send some photo electrons lights, and it can detect how much it can have, and also in the same way parallelly another type of like diode having, it detects how much it can the heart rate of the like that pulse waves. And also in that for example we can take the wearable watch, sir. In that the watch having some MEMS based sensor, sir, which can accurately base what type of pulse waves it can detect, and when changing the wave it can detects and sends to the microprocessing unit, and after that it can tells that from the microcontroller it can varies like that how it can convert from analog to digital converter, like that microcontroller like microprocessor like some of ESP32, Arduino and Raspberry Pi. They're part of a microcontroller it can have, and also the final output can display to the LCD output screen.
See, biological signals are analyzed with the help of digital signals. See, analog signals are converted into digital signals with the help of sampling, right? Digital signals are why they are analyzing biological signals in terms of discrete signals. They are amplified in terms of discrete in time and discrete in amplitude, and also for analog to digital conversion from analog domain to that can be converted into digital domain. For processing and analysis, how the biological signals can be processed means to extract the useful information from the noisy psychological parameters. See, psychological parameters is meant to analyze the blood pressure and pulse rate monitoring system, and also output and display. How to get the output means for analyzing, for pre-processing and analyzing the biological signals, we can get the output and the displayed for the LCD to monitoring the medical devices such as heart rate diseases, something, etc.
Next is the characteristics of signal, in which both the blood pressure and pulse signal are time varying physiological signals, and in blood pressure waveform typically represents the heartbeat races, which is systolic and diastolic phases. And next is the pulse signal, in which it reflects the expansion and contraction of heart, extraction of blood vessels as the heart pumps the blood throughout the body. And these both signals have a low frequency in nature and can be distorted by external noise sources. And with the help of the application of effective filtering and signal analysis technique, it can be monitored accurately.
Let us see the role of the signals and system using their monitoring process. Signals and system play an important role in the devices that monitor the blood pressure and the pulse. First, the signal from our body is continuous time signals, and they are processed to the systems like amplifier or the filter, which converts the useful information. And the next is filtering. Filtering is used to remove the unwanted noise like the movement or the electrical devices. And it may be used in the filtering process. And next, the signals is sampled and digitalized so that computer can process through it. The next type is the signals and the system can be studied, and studied in both the times and the frequency domains. And the time domains refers the signals over the time, and the frequency domain represents the which helps to detect the heart rate and the blood pressure to the frequency response. And finally, the engineers checks the system stability and the frequency response without the errors.
By applying the filtering and noise reduction, see, filtering means we are using some type of low pass filter, high pass filter, band pass filter, and also we can using the infinite impulse response filter and the finite response filter. Why these filters are used in psychological signals means to reduction in the noise of biological parameters. And also we are having this signal sampling. See, sampling is the process of conversion from your analog domain into digital conversion, right? With the help of these frequency and time domain analysis, how they are converting with the help of Fourier transform, they are converting the signals from your time domain into frequency domain, and also we can analyze the stability parameters.
Let me tell about the future extraction and the interpretation. When the signal is processed, the system starts to identify the most important features from the blood pressures and pulse waveforms. We all know that systolic pressure is the highest point in the pulse waveforms, and the diastolic pressure is the lowest point in the pressure waveforms. We can also find the pulse rate of a person by counting the number of beats that happens within a certain of time. By these values, we can also additionally find the mean arterial pressure. It tells about the how much are the average pressure that happens in the arteries during one complete heartbeat. By these extraction of these features, we can easily understand a person's cardiovascular health. By continuously monitoring this data and recording this data, it helps the doctor to identify and detect some early signs of any problems or diseases and abnormalities, and they can take a quick medical checkup if needed.
In practical implementation, we can use the both two sensors like PPG sensor and pressure sensor. PPG sensor matches 30102 for measure pulse rate, and the pressure sensor MPX 5050 to detect blood pressure. The both sensors are connected in microcontroller like Arduino. The microcontroller process and display the real-time data. Add Bluetooth or Wi-Fi for wireless data transfer. It is used for mobile apps or hospital systems. Useful for telehealth and home healthcare monitoring.
Now let us conclude the case study. See, with the help of these psychological signals, with the help of the digital signals. See, first psychological signals can be analyzed with the help of only digital signals. First, we can convert from your analog domain into frequency domain. Now, how their signals are analyzed? With the help of Fourier transform from time domain analysis to frequency domain analysis, right? Next one is your filtering. Filtering for, in case of IAR filter, FIR filter, used for biological signals for noise reduction. Now, by signal acquisition, filtering, transformation and analysis, convert the raw data into useful, meaningful information. Right? The successful implementation of blood pressure and pulse rate monitoring system demonstration has how engineering principles can enhance the human health. This is the case study about the pulse rate, blood pressure and pulse rate monitoring system. Thank you all.
Thank you, sir.